Welcome to the Health Headliner podcast by Tudu Digital. Our content is informational only and not medical advice. Please consult your provider. Now, let's dive into today's headlines.
Okay, so have you ever thought about how pain might be different for, men versus women?
Yeah, I mean, it's definitely something that's been, talked about more and more in recent years. Are there actual biological differences in how we experience pain?
Yeah, exactly. And it really got me thinking about it. There was this report from the Canadian Pain Task Force back in 2019, and it highlighted that chronic pain, like long-term pain, is actually more common in women.
Oh, wow, across the board.
Yeah, across all age groups,
Yeah.
even in children. So that really made me wonder what could be going on there, why is that?
It's a super interesting question. And, luckily researchers are digging into it. And for our deep dive today, we're going to be looking at this really cool study that's trying to understand why some pain medications might not work the same way for everyone, especially when considering biological sex.
Right, and this study specifically is coming out of the University of Calgary. We've got a couple of sources to help us unpack all this. There's this health news article that kind of summarizes the findings, but we've also gone straight to the source and looked at the original scientific paper published in the journal Neuron.
Awesome. Yeah, the more information, the better, right?
Totally. So our mission today is to break down what this study actually found and figure out what it means for how we understand pain and how we treat it, especially when we think about the differences between men and women.
Okay, I'm ready to dive in. So where do we start?
Let's start with the study itself. The research team in Calgary was led by this doctor, Dr. Tuan Trang,
Okay.
and they were at the university's Faculty of Veterinary Medicine and Cummings School of Medicine. So they were looking specifically at neuropathic pain. Have you heard of that before?
Yeah, neuropathic pain is the pain that comes from damage to a nerve or the nervous system, right?
Exactly. So think nerve injuries or conditions that affect the nerves. And they were particularly interested in something called allodynia.
Allodynia. That sounds familiar, but remind me.
Basically, allodynia is when something that normally wouldn't be painful, like a light touch or even a change in temperature, suddenly becomes super painful.
Oh, wow, that sounds awful.
It is. It can be really debilitating. And to get to the bottom of it, they used rodent models for this study, specifically rats and mice.
Makes sense. Rodents are often used in these kinds of studies, right?
Yeah, they're good models for understanding a lot of biological processes. And the first authors on this paper, by the way, were Chermi Wifan, Brendan B. McAllister, and Sierra Stokesek.
Okay, cool. So what did they actually find?
Well, one of the most interesting things was about these things called pannexin-1 channels.
Okay, pannexin-1 channels.
Pannexin-1. And basically, these channels seem to be involved in sending those pain signals in both male and female rodents.
Okay, so far so good. Pain signals. Got it.
But here's where it gets really interesting. These channels, they seem to work through different types of immune cells, depending on if the rodent is male or female.
Whoa, hold on. Different immune cells. I did not see that coming.
Yeah, it's pretty wild. So in the females, the female rodents who had a nerve injury, they saw that these pannexin-1 channels were activated in these specific immune cells in their spinal cords called, get this, cluster of differentiation 8 positive T cells.
Cluster of differentiation 8 positive T cells.
Yeah, it's a mouthful, right?
Yeah.
But basically just think of them as specialized immune cells, like little soldiers that target specific threats.
Okay, I'm with you. T cells fighting the good fight.
Exactly. And when those pannexin-1 channels got activated in these female T cells, it caused them to release this hormone, leptin.
Leptin. Isn't that the hormone that's connected to appetite and feeling full?
You got it. It's usually talked about with hunger and weight management.
Yeah, so what's it doing in the pain pathway?
Right. It's kind of a surprise. But it turns out leptin has been linked to higher pain sensitivity in women who have conditions like fibromyalgia and arthritis.
Really? So more leptin, more pain.
That's what it seems like. And in the study, they found that when these female T cells release leptin after the pannexin-1 activation, it seemed to be a major driver of allodynia in these female rodents.
Okay, so leptin's the key player in this female pain response.
And get this, when they blocked leptin in these female rodents, it actually reversed the allodynia.
Whoa, seriously. So they stopped the leptin and the pain from light touch went away.
Yeah, pretty amazing, right?
That is wild.
And they took it even further. They did these experiments where they transferred these activated female T cells, the cluster of differentiation, 8 positive ones, into healthy rodents. And guess what? Those rodents, then developed allodynia too.
Oh, wow. So they like transplanted the pain response?
Exactly. But, and this is key, if they blocked leptin at the same time that they transferred the cells, the allodynia didn't happen.
So it's like proof that leptin is the main driver in this female pathway.
It really seems that way.
Okay, this is all fascinating, but I'm curious, what about the males? Did they find the same thing?
Okay, so this is where it gets even more interesting. In the males, they also saw pannexin 1 activation after the nerve injury, but it was happening in a totally different type of immune cell, not the T cells.
Okay, so which immune cells were involved in the males?
These ones are called microglia. They're like the resident immune cells of the central nervous system, so in the brain and the spinal cord.
Interesting. So different immune cells, different location even.
Yeah. And in the males, when pannexin 1 was activated in these microglia, it caused them to release something called vascular endothelial growth factor A.
Vascular endothelial growth factor A, that's a mouthful.
I know, right? But basically, it's involved in the growth of blood vessels.
Okay, so how does that relate to pain?
Well, it turns out that besides growing blood vessels, vascular endothelial growth factor A can also activate those nerves that sense pain.
Huh, interesting. Multitasking molecule.
Yeah, and the researchers found that in the males, this release of vascular endothelial growth factor A from those microglia seemed to be contributing to their allodynia. And just like they did with leptin in the females, when they blocked vascular endothelial growth factor A in the male rodents, it reduced the pain they were feeling from those normally non-painful things.
Okay, so we've got two totally different pathways here. Females, it's T cells, pannexin 1, leptin, and allodynia. Males, it's microglia, pannexin 1, vascular endothelial growth factor A, and allodynia.
Exactly. And they did those same transfer experiments with the male cells, too.
They put the male microglia into healthy rodents.
Yep, and it caused allodynia in those rodents. And they could prevent it by blocking either pannexin 1 or vascular endothelial growth factor A.
So again, they pinpointed the specific players in the male pathway.
It's like men and women are speaking different languages when it comes to this kind of pain. Like,
Yeah.
at the cellular level, their bodies are doing totally different things.
That is mind-blowing. So what does this mean? Like, big picture, what are the implications of this finding?
Well, one really important implication is that it could help us understand why some pain medications work better for men than women. The Nuge article pointed out that a lot of the research that's been done on pain in the past has focused mostly on male subjects.
Oh, wow. I didn't realize that.
Yeah, so if those medications were developed based on what they saw in males, they might only be targeting that vascular endothelial growth factor, a pathway that's more important in men, and they might be completely missing the leptin pathway that seems so crucial for women.
That makes a lot of sense. So, like, some women might not be getting the relief they need because the medications aren't designed to address their specific pain pathway.
Exactly. And Dr. Laurie Montgomery, who is a pain clinician at the University of Calgary, said that this study's findings really line up with what doctors have been seeing in their patients. You know, women are more likely to experience chronic pain, and they don't always respond the same way to treatments as men do. She even suggested that this research could be like a huge step towards personalized pain treatment, where doctors take biological sex into account.
Wow, personalized pain medicine, that would be amazing. Imagine getting treatment that's tailored specifically to your body and how it experiences pain.
I know, right? That would be a game changer for so many people.
For sure. So what about pannexin 1? Do you think this means that it could be a new target for pain meds?
That's what the researchers are suggesting. Because it's involved in both the male and female pathways, they think it could be a really valuable therapeutic target for neuropathic pain in general. But they also emphasize that any treatments targeting pannexin 1 would need to be sex-specific.
Yeah, that makes sense. You'd want to target leptin in women and vascular endothelial growth factor A in men, right?
Exactly. So basically, one drug wouldn't work for everyone. You'd need different approaches for men and women to really address those underlying mechanisms.
This is all super promising, but are there any, like, limitations to the study that we should be aware of?
Of course. It's important to remember that this was all done in rodents. So while it gives us some great insights into how these pathways might work, we need to do more research to see if the same things are happening in humans.
Right. Rodent models are great, but they're not always perfect representations of what happens in people.
Exactly. Plus, even though they found that leptin is really important in those female rodents, they still don't know exactly how it gets released from the T cells when pannexin 1 is activated. Like, what are those specific steps inside the cell?
Okay, so there's still more to learn about the fine details of the pathway.
Yeah, For sure. And we also have to remember that there are a ton of different immune cells in our bodies, and they're all interacting in complex ways. So this study is really focused on a specific subset of cells, and there's a lot more research that needs to be done to understand the bigger picture of how the immune system contributes to pain.
So it's like a snapshot, a piece of the puzzle.
Yeah, a really important piece, but still just one piece. And one other thing, in the scientific paper, they mentioned that they used a specific type of mouse for some of their experiments. It's called the CX3CR1 Cree mouse line.
Okay, and why is that important?
Well, they used it to study the microglia, but this type of mouse, it doesn't target only microglia. It can target a bunch of different immune cells.
Ah, so it's not as precise as it could be.
Exactly. So they acknowledge that in the paper and say that more research is needed to really characterize all those different immune cells and figure out exactly what roles they play in pain.
It's so cool to see how much we're learning about pain and how complex it is.
It really is. So I actually wanted to share some quotes from the researchers themselves because I think it really highlights the impact of this study.
Yeah, I'd love to hear what they have to say.
So Dr. Tuan Trang, he emphasized that their work shows that while both males and females can develop pain, they do it through these distinct biological pathways.
That's what we've been talking about, right? Men and women are different at the cellular level.
Yep. And he also made a really important point about how a lot of the research that's been done in the past, like preclinical research, has really focused on male subjects.
Oh, wow. That's a big deal.
It is, because it means that any treatments that are developed based on that research might not be as effective for women because they're not taking into account those female-specific pathways.
That's huge. It really highlights the need to include both sexes in all kinds of research, right?
Absolutely. And Dr. Laura Montgomery, the pain clinician we talked about before, she agreed with that. She said that doctors have known for a long time that women are more prone to chronic pain and that their responses to treatment can be different. But she thinks this research could be a real turning point in developing more personalized and effective pain treatments that are tailored to each person's sex.
That's really exciting. So what's the take-home message here? Like, what should we as listeners be thinking about after learning all this?
I think it really challenges us to consider that biological sex might be a huge factor in how we experience pain, both personally and in the people around us. Like, it makes you realize that pain isn't a one-size-fits-all experience. There are these fundamental biological differences at play.
Yeah, and it makes you think about what this means for the future of pain research and treatment. If we can really understand these differences between men and women, can we develop better, more effective pain relief?
Exactly. It's like, could this be the key to a future where pain management is actually tailored to each person's biology?
That's a powerful question.
It is. So just to kind of summarize everything we've talked about today, this research from the University of Calgary has given us a new biological explanation for why pain might be experienced and treated differently in women and men. We've learned about how important those different immune cells are, the T cells in women and the microglia in men, and how they release these different molecules, leptin and vascular endothelial growth factor A, that seem to drive pain. And it all starts with the activation of those pannexin-1 channels.
It's amazing how much we can learn from these kinds of studies, right? Like going beyond just the headlines and really digging into the details, it gives you a much deeper understanding of these complex biological processes.
Totally agree. It's been a fascinating deep dive. Thanks for joining me.
My pleasure. And to everyone listening, thanks for tuning in. And we hope you'll join us for our next deep dive into the world of science.
Thanks for tuning in to the Health Headliner podcast by To Digital. Like and subscribe for more health news and breakthroughs. Stay healthy and informed. See you next time.